Welcome everyone to this seminar organized by the MoBILE research program in collaboration with the focus research area on e-health. I am Preben Benson, who will chair this seminar, professor in public health and social medicine. And today we have three presentations. It is Claes Lundström, who is research director of the MTech company Sectra, and also adjunct professor at Linköping University. And then we have Håkan Gustafsson, who is the AI coordinator in Region Östergötland and also adjunct senior lecturer to Linköping University. And then we have Professor Lars Sandman, who is professor in health economics and prioritization of healthcare. And the focus of all three presentations will be the role and ethical consideration concerning artificial intelligence in decision support in the healthcare. So welcome everyone, and I'll hand over the word.
Well, thank you very much for inviting me. Very happy to be here to talk about AI in healthcare. And well, with my background that you heard about, you're going to realize it's going to be a bit focused on imaging diagnostics, but that's also a very prominent area in AI in healthcare, so kind of leading the way, so it makes some sense. I also have an assignment to mention that I'm heading the national arena for AI in imaging diagnostics called ADA that we host here at CMIV and Linköping University. So I'll start off with a bit of overview and then drill down to more practical, concrete considerations. But I'd like to start with this metaphor of AI being like electricity. I think it's very illustrative that it shows the potential that AI might have. I mean, it can really make a big difference in healthcare in many places, and also like electricity everywhere. It's going to be providing those benefits on a wide range of anywhere where we have structured data, we have a possibility to get assistance from AI. And also a bit, I think it's a good metaphor of where AI has been at least kind of very hyped and almost perceived as magical. I think we are maturing, and we're soon getting into this same mindset that we have for electricity, that yeah, we know what it is, we know how to deal with it, and it's not so mystical anymore. So that's the first takeaway here, that we have to realize that when people talk about AI, they can mean very different things. Some really like the science fiction aspect of AI and to be very philosophical about will robots take over the world in some distant future. But what I'm talking about is very much here and now, very we call it weak AI, we call it narrow AI. It's something that is simply a tool for us to use, and we are very much in control of and understand how it works. But of course comes with some challenges that I will be discussing. So I'm not so interested in the science fiction discussion. Some are, but it's important to keep them apart, I think. So first thing to mention is, of course, the potential that AI has, and that's been shown over and over again in more and more high quality studies, so especially in imaging diagnostics. So this is from this year, and mammo screening. I guess most of you know very well the ROC curve. You know that one wants to be in the top left corner there in order to both have high sensitivity and high specificity. And as you can see, the standalone AI in this case outperformed both general radiologists and breast specialists in the screening task. And it's the same similar studies we have in pathology as well. This is Gleason grading, big study from early this year from about in Netherlands. Basically, what they conclude here is that the deep learning system is like one of your better colleagues, like the top third of the pathologists that were participating. So that type of performance is what we can expect from research studies on AI. And we also have, since modern AI kind of started in 2015, and then a lot of investment, and now we're seeing the results in the form of regulatory approved products from the last couple of years as well. Not still, it seems like it's plateauing rather than exponentially growing, but still it's a number of things to choose from. But then we can come also to what's actually being used out there today. This was the survey that Östergötland did last year, and the dots here represent some solution that the care providers in Sweden has reported that they have. And I still feel like it's a couple of hundred here or so, and I feel that that's pretty low compared to the potential that we know that AI has. But still, looking closer in those dots, they have different colors, as you see, and actually some of them are just research projects. So let's kind of remove them because they're not being used. The blue dots are something that we're soon going to deploy them. I'm a bit cynical. I think that soon is often quite far away and sometimes never. So let's remove those as well. And then you have actually the definition that Socialstyrelsen used for AI is a bit questionable, I would say. So they also asked for rule-based systems. I would not really consider that AI. We can discuss that, but still it's not what we mean by the modern hyped AI that we know from deep learning, etc. So let's remove those. And then of the remaining ones, well, there was AI before this last way of really, really high performing AI. And now I'm only speculating, but I would guess that at least half of these are old school AI. So I don't know if we really should count them in state of the art usage of AI. So then the picture is kind of almost depressing in the sense that how much are we actually taking advantage of this technology out there in healthcare today? And what do we have? Well, we have speech recognition is one really good example of state-of-the-art AI that's really out there also in our daily life and also in healthcare. Chatbots are there. And then the last point is actually imaging diagnostics that you see bottom right there. Okay, so some key insights about where we are. This image that I'm painting is really summarized by this picture. We have on one hand extremely promising results. We have the graphs that I show you. The potential of AI is huge that we can show in really good research studies, but they are retrospective. They are in a lab setting, and actually going all the way into the clinical wilderness and making this work in a hospital has not really been done in any large scale yet. I don't know of any prospective studies showing that AI has modern AI has accomplished benefits in terms of increased quality of care or cost effectiveness. So obviously it is quite difficult to take this step, and one part of it is that in general it's difficult to introduce medical technology, obviously, but there are some special considerations that we need to have when it comes to AI. So I'll talk a bit about a few of those things. But how can we understand this seeming paradox that on one hand this is best thing since sliced bread, it's extremely powerful. On the other hand, it's very difficult to put to use. Well, this is an illustration I like to use. If you think about the landscape of diagnostic tasks that, for instance, a radiologist does during a day or during a week or during a year, and this is the landscape here. And then we make the height of this landscape be how good an AI application can help out with this subtask today. Well, then we see a landscape that there are these very high peaks that we've seen in the studies, but we also see that they are very, very narrow, and the landscape is very sparse. So this is can be very difficult to put to use. For instance, very few times the radiologist just has a very defined a narrow task to do. The radiologist has 100 tasks to do when looking at an image. So it might be difficult to make use of these algorithms, even if they are very narrow. And it's also, the narrowness is also a problem of robustness. As soon as you go slightly outside of that peak, you're in trouble. So let me show you an example. This is from a study a couple of years ago that was aiming to create automatic captions for images, images that hadn't been seen before just off the internet, and then you should create a nice sentence describing what's happening in this image. So they trained the system for I don't know how many thousand images and captions, and then this is from the test they did. So they throw this previously unseen image at the AI model, and it comes up with a woman is throwing a frisbee in a park. I think it's amazing, and this is, I think it was 5 years ago already. So I mean, this is really, really impressive that they can understand what's in the image. They can find out that the red thing at the board there is the most important thing. We would think as humans what's happening here. Another example is this one. Also lots of opportunities to make mistakes here, but the AI model pins it perfectly with a group of people sitting on a boat in the water. And the third example is a large white bird standing in a forest. For this image, which obviously is not a large white bird standing in a forest, it's a slightly overexposed double giraffe. So the point here is not that this model is stupid or poorly trained. It is simply the fact that we haven't trained it on double giraffes. If we had trained it on double giraffes, it would have learned double giraffes, no problem. But that's a very fundamental thing for AI. We train it by examples, and how can we be sure that we've trained on every situation that we will use the AI for in the future? Well, the answer is that we cannot. We can do as good a job as possible, but we also need to handle AI with care when we use it. We need to do evaluations. We need to do monitoring much in the same way that the physicists today are working with continuous monitoring of that the computer tomography scanner still works as it should. Another very important part is that, as I said, these algorithms, they are learned by examples. So that means that they learn from historical data. And they are extremely powerful in picking up these patterns from historical data, much better than humans in many cases. But it also means that if there are any biases or flaws in the historical data, we will surely cement those for the future. So, I mean, if we do poor quality of care previously, we will cement that and do exactly the same level of poor in the future if we just go by the historical data, right? Or we could have inequalities. We know that sometimes we treat women or certain social groups worse than we should. Well, that will be preserved if we just take that as the ground truth, right? So we have to understand this and treat it with care as well, and understand that AI can be very powerful, but not maybe that change agent in all aspects that we would want. So I'd like to highlight a few key considerations. What should you think about when you want to develop AI? Well, in healthcare in general, I would say, but my examples will be from diagnostic imaging. The first success factor is to be really careful with defining the problem. It sounds very obvious, but this is something where a lot of these initiatives go wrong. It is technical people that you know, they know the technology, they think they have understood what the clinical problem is, and they go ahead and do something that has really nice sensitivity and specificity. But when you go to radiologists and pathologists, they would say, well, that's nice, but it doesn't help me. That's not what I wanted AI to help me with. And it can be quite subtle in the differences there. So you really need to do your homework, and it really needs to be healthcare in charge of putting the right requirements to the technical people in collaboration with them. So take one example, a common application for radiology and AI is lung nodules, a very high task that radiologists do a lot, and that's fairly easy to do, but takes a lot of time. So it's something that they really would like to help with. But the question is, exactly what do they want help with? Well, it depends. Is it a detection task? Is it about finding the nodules as such, which might be useful if you want to make the normals review faster, because that's takes a lot of time. But if you have a high sensitivity detector saying that there's no nodule in this case, well, then you can be much quicker in working through it. Then it's a detection task. But maybe it's about it takes some time to make these measurements. We need to know if these are growing or not, so we need to report how big they are. But maybe I want help with the measurement. I can find them myself, but then you need the boundaries, and that's a segmentation task. Or is it a problem of quality care that in certain cases are very difficult, and we want AI to help us with the classification or grading of different types here, because that's important for the treatment of the patient? Well, that's a third task. It's a classification task. And it could be combinations, of course, of these things. But deciding this, really, you need to do that from the beginning, because the AI will be trained on training data, and we need to gather those ground truth annotations, and they're going to be very different. If it's a detection task, it's just a point coordinate that we need. If it's a segmentation task, well, then we need full boundaries to train on, etc., etc. So it really comes in early in the AI project. It's not something we can do afterwards. And important pitfalls here are that it's quite easy to create AI that actually is intended to make you more effective and efficient, but it actually creates more work. And high false positive rates is one such pitfall. If you typically you want high sensitivity, right? You don't want to miss anything. Well, if your AI is not perfect, that means that you will have a lot of false positives. And it actually can take more time to go through the false positives and rule them out than was actually the work that you did pure manually before. So you need to think about what is the actual scenario here, and what type of performance do we need? Is it high sensitivity that is the main thing, for instance, or should we find some other sweet spot of this model? And then we have also the automation can be problematic for how the human expert actually does its work. We've seen this in other areas. We've seen it, well, it's still debated, but there was a big study on the old AI, computer-aided detection used for mammo screening in the US. And the idea is to use AI, the man and machine, in a combination, that their strengths should be combined. And that what was the lab study said, that if you combine them, it will be better than just the man alone. The problem was then that used at large scale, it seemed like the human experts became slightly less sensitive and slightly overconfident or trusting the AI too much. That was not the intention, but it can easily happen if something that is typically very good and it provides you with nice exact numbers of I'm 95% sure that this is cancer. It's kind of difficult to have your own level of confidence to contradict that. So we need to work with that aspect as well. Second one is to get the right data. Very, very important to get the right representativeness as we talked about the double giraffe problem. And this can also be very subtle. So this is something, this is an example of an effect we've seen in several cases as well, was just discussed at the radiology conference in Chicago this week. But this is an example. A couple of years ago, a researcher was blogging about that they were doing an AI algorithm to detect things in chest x-rays, quite a common task as well. So for instance, detecting pneumonia in this case, but they also made a double check to see, okay, it seems to be doing reasonably well here with the predictions, but we also want to see where in the image it thinks its most important parts in order to make this decision for pneumonia. And as you see in the heat map there, the high numbers means that it's important, and many parts of that is in the right lung, which is good. More surprising is perhaps that the left arm is also considered important. And what they realized is that it was actually picking up on the text that was burned into the image. The text portable means that this was taken by portable X-ray equipment. When does one use portable X-ray equipment? Well, that's when the patient is too sick to go to the radiology department. So is there a higher probability that a person taking an X-ray from portable equipment has pneumonia? Well, absolutely. So it really picked up on this rather than looking at the actual features of the lung here. AI will use anything that has at hand to make its predictions. And if we want to avoid this, I don't know if it's good or bad actually, but if we want to avoid this effect, we need to be careful when we work with our training data. And then the third and last point here is do your interaction design homework. So much is being done on the AI model development side, and people think that they are ready when they have the high performance numbers of sensitivity and specificity. And I would say that this next part of how you actually present the results, work together with the human expert, is just as important, sometimes even more important, but actually getting a lot less attention, a lot less investment in all parts of the pipeline. So just a simple thing that always should be there, of course, as soon as we have imperfect AI, and we always have imperfect AI, we need to be able to control the results. We probably need to be able to correct the results. So again, going back to the lung nodules, this is how it works in the sector system with the third-party vendor bringing in those results. You have a quick way of going through those findings. You can accept them or reject them quickly, but you also can go in there, and if you think the outline was incorrect and the measurement was incorrect, you can change that and then accept the finding. So finally, summarizing, AI is an effective tool when you do your homework in identifying at some granularity a relevant problem for healthcare that is suitable for AI. You need to put a lot of effort into gathering data, annotating the data, cleaning the data. You ask any AI developer, they would say that this is what takes vast majority of the time developing AI. And you need to be very thoughtful in terms of getting the representative data. Are all possible situations covered? Are subgroups covered in a good way, etc., etc. Consider interaction design and human-computer interaction aspects, and make sure you seamlessly integrate this in a workflow. You don't want, as a physician or healthcare professional, to have to go away to another workstation or enter the patient's data one more time to search for it. It should just be there. And that's also a main pitfall to avoid. You need to have it seamlessly integrated. Thank you very much.
Okay, so I would like to present artificial intelligence within Region Östergötland and the vision and strategy we are developing for the future of AI within Region Östergötland. So I will give a short introduction and the aim of this work, and then I will give one example of the projects we are starting up, and then something about legal and ethical considerations that we have encountered already. And then I will give a brief introduction to a routine we are creating for the implementation of AI tools within Region Östergötland. And then I would like to say something about the vision, strategy, and the future work we are planning. And then I was hoping for a discussion, but then that will be in the end of the seminar instead. So something about the introduction. That, of course, accurate and comprehensive healthcare data coupled with modern analytical tools is, of course, a key for improvement of healthcare system. And this is, of course, no new knowledge. It's a lot of textbook exist, of course, in the matter that you need to understand the data of your healthcare system in order to improve the healthcare system. However, this data is fragmented and distributed. There are different type of databases, and it's very hard to get an overview of all the data regarding, for instance, one patient. And there is not only technical problems to have this data gathered. There is also, of course, what we are discussing here today, the legal and ethical problems with gathering data. The aim we have is to develop a strategy for Region Östergötland, and some of the aims are that we would like the more easy access of data for development of the clinical workflows, and of course, but also to have data that are more easily accessible for research projects. And we are also discussing the ownership of data. Of course, the ownership of data is already in most cases no problem, but it can, for instance, be in a file format that is very difficult to extract the data you would like to have for a project, for instance. And we also would like to have an increased ability to develop AI models where the need is large. Right now, there are some very good research groups distributed within the Region Östergötland, but there is not, how to say, a central group that can develop AI models where the need is large. It's more based on good researchers that and which work at their own clinic, but there is a lack of knowledge, how to say, from a management point of view to develop models where the need is large. And the aim of this work is also that we have already understood that we lack legal competence within the Region Östergötland, and that creates a lot of problem for those AI initiatives we already have. it can be related to, for instance, which data can you use to train AI models. However, when in some cases there have been projects that has been running for quite some time, and then suddenly we understand that there is legal problems making it impossible to use the data to train the AI models. And of course that is a waste of time, and it should have been settled before the project started. So the aim is that we need to have an increased expertise of what we can do with the data within Region Östergötland, and that expertise need to be more closely related to the groups that are doing AI research and AI projects. And then we also have the aim that we need to understand how we can manage AI tools in a clinical setting. We need ability to understand the framework of how to adapt AI tools when they are in real clinical production. It's one situation when you are doing a research project, but it's a completely different thing if you are really implementing the AI tool in the clinical workflow. Then someone needs, of course, to oversee that these tools keeps on doing the right things and giving the right answers. And so we need to, how to say, develop some kind of structure within Region Östergötland that can control and manage AI tools. So to the left, I try to illustrate what you would like to have. Of course, you would like to have a lot of AI tools that can help the healthcare system to do very good stuff and so. And to the right, you have what you encounter in the daily life at the clinic. For instance, it's a symbol of a fax, for instance. I used to work at, for instance, radiology in Norrköping, and then we tried to get rid of the fax, but it turned out that it was a crucial part of our communication with private care and also a crucial part of the transfer of radiology reports during nighttime. So it's two very, very different worlds, that what we see in the research and the daily clinical use, it's a very big gap in the technology there. So it's our goal is, of course, to be able to implement AI tools in the daily life at the clinic, but there can be quite some big steps before that can happen. Okay, so one example that I hope that we can start with within the next year is a project within mammography, where we have an ethical permit now to use one AI tool to for mammography screening. And this project will be that we will simply study the performance of this AI tool in a clinical workflow. So the study is not, how to say, to develop an AI tool. It's simply to take one of the commercially available tools and study its performance in a clinical workflow here within Region Östergötland. So that is one example of what I hope to accomplish during the next year. Simply taking commercially available tools and study their performance within Region Östergötland to see if it's if the quality is if the tool is still working in a real clinical workflow, and if it's cost effective, and if it's really useful for the radiologist. Can it, for instance, give them more time to discuss complicated cases? Can it reduce the need of double referring, for instance, and so on? So it's one example. In this case, the AI tool give a score of the likelihood of cancer, and it can also be used to study areas which looks suspicious. And in this example, we are planning 4 phases, and we have ethical permit for the first phase of the study, and it will simply be that the clinical workflow will keep on as normal. 2 radiologists will look at all images, and those images that look suspicious go to a meeting where it's discussed if it's if they suspect cancer or not. And our AI tool will be in a parallel workflow and will add some cases to this discussion. And we will study the performance of the AI tool, sensitivity, and so forth, and also study what it means to the radiologist in their daily work life. And what we have already encountered here at Region Östergötland when we are starting with AI projects is, of course, the legal aspects. How can we use the data that we have within Region Östergötland? And it is, of course, a difference depending on the purpose. For instance, if it's a research study, you need, of course, ethical permit and so forth. And but otherwise, you can do this development projects or verksamhetsutveckling. Then there is different regulations, and you need to navigate in this landscape. And of course, we have seen in some project that care across a fragmented healthcare system can be complicated when regarding the data. You have multiple clinics, lab data, and some data are in the kommuner, and some data is within Region Östergötland, and so forth. So we need to understand how and which data can we use, and what are we allowed to use, for instance, to train an AI model. And then, of course, we have the discussion regarding anonymized data or use of personal data. And we have, during discussions with AI researchers, understood that, of course, it would be better if we could train our model on, real data with all personal information still present. But in some cases, you need to export the data, for instance, to Linköping University, and then, of course, it needs to be anonymized. We have also different regulations regarding anonymized data. I was naive and thought that as long as the data is anonymized, it's quite fairly simple to use in, for instance, a research project if you have ethical permit. But it has turned out that there is a lot of different regulations also, can be problematic when you would like to use anonymized data in a research project. And then, of course, we have these discussions regarding cloud computing, cloud storage, transfer of data to third country, and we have within Region Östergötland several people working with these type of questions, and there has been strategies regarding, for instance, cloud-based computing and so on. So it's how to say, a lot of ethical considerations and discussions and obstacles for instance, research project. So the how to say, the work we do in order to make it more easy to implement AI tools within Region Östergötland is that we, for instance, have started with a routine, and the purpose of this routine is to help clinics, help AI initiatives to understand what can they do with their data, and to help for instance, a head of a clinic or a AI initiative to understand which type of data can be used and which permits do you need, to distinguish between if it's a research project or if you simply would like to improve your the workflow at your clinic but not interested in a research project. We have this discussion if are you interested in developing your own AI tool, or would you like to implement a commercially available tool? How can you work together with a company in a joint project, and so forth? So it's a work in progress, and my hope is that this routine will help different clinics within Region Östergötland to make it more easy for them to start their own projects. Okay, a few words about the strategy we are starting. Our vision is that the use of AI within Region Östergötland leads to a substantial increase in quality and efficiency in healthcare, but not only healthcare, we also like the same thing to happen in dental care, public transport, and of course internal administration. And we say that AI contributes to good living condition, equal health through the proactive use of health-related information. And we would like to implement the same type of development in public transport, and that we make data more easy available for research and development of new AI tools. So this is the vision we strive for, and our strategy is that we are we work a lot trying to make the data within Region Östergötland a strategic resource. This means that we hope to when we purchase new IT tools, for instance, we would like it mandatory to have data in an file format that can be easily extracted and understood by researchers and developments. And we hope also we would like to build an expertise regarding what we can do with our data. So we would like an expertise that can work together with clinics where the need is large for new AI models, and also with the hope to provide infrastructure for information-driven care, precision medicine, and precision diagnostics. So it's into the, how to say, storage of data and make it available for development and research. And then we the strategy is to build knowledge so we can implement and manage AI models and tools at different clinics. And then, of course, we need to develop, build legal expertise, not how to say, not only build that, we think we need to build this expertise within the group that are working with the data and implement AI tools. So how to say, legal expertise within the project groups. And what we, of course, hope to achieve is that, how to say, increase knowledge of care patterns, so we can, how to say, follow, for instance, standardiserade vårdförlopp to understand those better and to see the performance of different parts of that. And then the hope is, of course, that we could, using this data and advanced tools here, for instance, measure compliance with established clinical guidelines, and then, of course, assurance of the clinical quality and cost effectiveness. And then, as I have already discussed, make data more readily available for research and further development of the healthcare system.
I will say something about the ethical aspects of AI. I hope you see my presentation. So, I mean, talking about ethical aspects of AI is like talking about ethical aspects of everything, almost, if we so talk about it in this very broad sense. And I would say that the type of AI we discuss raises very different, or at least somewhat different ethical aspects. So, I mean, what we're going to talk about today, decision support systems, where the humans decide in the end, will raise some ethical aspects of questions. If we have decision systems that actually decide in healthcare, for example, where humans simply implement the decisions from the system, will raise partly other aspects or ethical aspects. If we have autonomous systems which actually decide and implement their decision in some way, and I've illustrated it with the autonomous cars here, I mean, that will raise even more ethical issues that we need to discuss, and that's of course interesting, and that's why I show you the picture of a traditional philosophical example where you have a tram and you can decide whether it should kill one person or several persons, and those kind of sort of philosophical or ethical methods are now of course used when sort of developing these autonomous systems. Once again, that raises other ethical issues. If we would arrive at what Claes talked about, the more science fiction sort of aspects of this generalized AI, which is closer to human intelligence and multifaceted, that would raise other ethical issues. And finally, if we reach the so-called singularity, where we humans probably are outdated by AI, that would raise perhaps aspects that we might even not even imagine at the moment. So to talk about AI, we need to sort of decide what are we talking about, of course. So the focus today is decision support systems in healthcare. And I will just briefly mention a few aspects here: patient autonomy, professional autonomy and responsibility, privacy, justice and equality. And of course, there are a number of other ethical aspects that we could discuss: patient responsibility, for example, or physical integrity, if we talk about implementing or actually inserting AI in people's bodies. Human dignity, perhaps, if we are talking about AI that would in some way change people's powers or people's personalities or things like that. But I will not touch upon that today. And I will finally say something about a structure for ethical analysis of AI technology and the need for that. So my take-home message, or my central message, if I have one, is this, that we actually need to do sort of concrete ethics analysis of specific technologies, since, I mean, AI or AI technologies are seldom or perhaps never unethical or ethical per se. They always have sort of ethical aspects we may need to take into consideration, and these ethical aspects might actually differ depending on the organizational context or setting where we are going to use them. So that's why what I will be talking about in this seminar is more like potential ethical aspects that we need to be sort of observant upon. And of course, generally, AI is something that could help us to handle human biases that sort of distort our decision making. And just to mention one such bias is that's the so-called decision fatigue. It's been showed in numerous studies, and this study is of Israeli judges making decisions of parole, where it's shown that they have a high inclination to say yes to parole earlier in the day, and then it sort of goes down before they have their first break, and then when they have had a snack or eaten something, it goes up again, and then it goes down. And things like time of day and food seems to affect our decision, and it's been shown also in Swedish studies about healthcare decision making. So of course, AI could help us to sort of remove these biases. So that is, of course, a good thing from an ethical perspective, and I will return to that. Talking first about patient autonomy. I mean, patient autonomy is a very strong, or respect for patient autonomy is a very strong ethical norm in Swedish healthcare and in healthcare in general, at least in the Western societies. And something that we are, in a sense, developing in the healthcare system at the moment. We talk a lot about person-centered care, where we try to sort of adapt the healthcare system to allow patients to have more influence and to listen more to patients than we have done previously in a more paternalistic society and a paternalistic healthcare system. And of course, these decision support system can actually empower a patient, perhaps, or perhaps enable patients to make better decisions. The recommendations might be more individualized. The specific patient might get more specific information that is actually relevant for that person, and not just sort of for a statistical person or statistical individual in a clinical trial or something like that. And of course, that would be a benefit from a patient autonomy perspective. On the other hand, there are, of course, potential problems. I mean, one of the things especially with person-centered care, is the emphasis on sort of negotiating between the patient and the professional, sort of trying to find what is best for me, but not only best in terms perhaps of efficient or effective treatment, but also best based on my values and aspects like that. And it could be the case that, I mean, if the AI, if the information, if the decision support system gives one recommendation based on what works for a patient, that would leave, in a sense, less negotiating space. Might not be a great problem, but it might be experience from the patient as not having much to say in this discussion. It might be a problem, of course, depending on how the decision support system is used. Who am I negotiating with? I mean, if the professional refers to the AI system, that this is the information we got from there, that might perhaps make it more difficult to see who am I actually negotiating with as a patient. And of course, if we develop AI and AI systems that will give lifestyle recommendations or trying to nudge people to act in a specific way, that could be seen as restrictive of autonomy. There is a discussion about this, and a new term called libertarian paternalism is something, a term that is used in relation to this, and we might discuss where do we draw the limit when this kind of sort of nudging becomes potentially problematic from an autonomy perspective. But these are things that we might need to be a bit observant upon. Talking then about professional autonomy and responsibility. Once again, of course, a decision support system can enable professional decisions to rest on better information, and thereby perhaps also make professionals more confident in their decisions, easier to sort of take responsibility for. On the other hand, a potential problem that was sort of touched upon by Claes is that, do we actually uphold competence? Do we retain the ability to sort of discover faulty recommendations or faulty information in the system if we sort of allow a lot of the information or information processing to be done by AI? That could, in a sense, also reduce professional autonomy. As a professional, you don't find that you have as much leeway to decide on what kind of treatment should we give in this situation, etc. And also something that is perhaps both an ethical but also perhaps also a legal aspect is, where does responsibility rest if the recommendation or the decision goes wrong, and if the decision then is sort of primarily based on information from the AI? So those are things that we might need to sort of discuss and be observant upon. Looking then at privacy, and Håkan touched upon this also in his talk, decision support system, and of course that is one of the main advantages of them, is that they might help us to handle big data from different data sources, both inside and outside healthcare. And this raises obvious problems, control over data, both for the patient and for the professional. Can we be sure that the data is actually used for the right purposes, or could it be used in a sense against us? I mean, for insurance purposes, or when we are applying for employment, or other aspects like that, where data can be used sort of against us and not only to further our health. So, and do we have enough security against this? And of course, here we have a sort of face a potential conflict, because, I mean, the best AI perhaps we could develop if we have less borders between different data sources. If we can actually use data from different sources, that would give us a strong tool, of course. And if we sort of secure ourselves too much against that, that then the AI will become, in a sense, less effective. On the other hand, then we might have a greater privacy problem. So here we have sort of a balancing of different values. Talking about justice and equality, once again, decision support system might contribute to less biases. We know when we look at these biases I mentioned earlier, that they do tend to make it difficult to sort of prioritize between different patients and treat patients equal. We are affected by our biases in different ways. These support systems might also, of course, enable us to use our resources much more effective. I mean, if we have support systems that sort of can pinpoint which patients that are actually going to have a good sort of benefit from a treatment, and not just having to sort of treat the whole statistical group, that is, of course, a more effective use of resources. On the other hand, there are potential problems. Claes mentioned the biases that might be imported in the decision support system if we sort of use historical data, and we have seen examples of these systems even becoming more consistent in their discrimination, in a sense, which is, of course, a problem. And the other aspect is that technology has an opportunity cost. I mean, the resources or the investment in technology is an investment where we take resources from something else we could have done, of course, in the healthcare system. And that also raises question, when in sort of the development phase of a technology should it be implemented? I'm involved in decision making at the national level on prioritizing new technologies, mainly drugs, but we have also had to deal a little with medtech products. And one thing that strikes me there is that there's a very strong development over time. So, I mean, a new version could arrive every half year or every month even, and that causes sort of problems in the system. When should we actually implement it? When should we do this investment in the technology? Should we wait further to have a sort of even better system, etc.? Another aspect of this is for which groups do we develop technology? Looking at the Swedish healthcare system, it's a needs-based healthcare system where we have a set of priority setting principles that decide which groups should we focus on mainly. And of course, do we allow that to drive also the technology development? We haven't seen that perhaps in drugs development. So there might be a problem also here, that the technologies that are developed doesn't really target the where we have the large healthcare needs, for example, and that is something that we need to deal with then. Another perhaps a bit more far-fetched aspect, but still something that could be a problem, is especially if we have systems that collect data and give recommendations about people's lifestyle. We have a discussion, and as a recurring discussion in the Swedish healthcare system, should we sort of take into consideration whether people have done the right health choices historically? I mean, did they smoke, or did they exercise enough when they get their lung cancer or their prostate cancer or their cardiac issues or whatever? And we're not allowed to take that into account in the Swedish healthcare system as of now, but I mean, that could change. And of course, these kind of systems, especially if we collect individual data about patients, could be a very good tool to say to a patient that unfortunately you didn't do well in your health choices historically, so you will be given a lower priority. And that is also something we need to deal with. So just a brief overview of a number of aspects that we might have to take into account, and we could sort of make the list much longer, of course. All these different values calls for balancing. I've tried to indicate that all technologies will have sort of benefits, but also potential adverse effects, and we need to balance these values. And I would claim that that can only be made given a specific technology used in a specific organizational settings. And sometimes, of course, we could adjust both the technology or the organizational setting to sort of accommodate these ethical problems or aspects. So I think we need to develop a more formalized perhaps structure, and we also need to develop the competence for ethical analysis. And I'm glad that Håkan raised that issue too in his talk. We have some, I mean, there are, of course, to some extent this competence, but I think we need to sort of find a proper way to do it. We have actually established this year a new national council. The different regions have established a national council called the MTP Council, which is a joint function for recommendations on the introduction of new technology in healthcare. So MTP stands for medtech products. That could be one such function. That would, of course, delay introduction, but it might make introduction more sort of well established or and also equal over the country. So that could be one such function, but I think we need to develop that structure even more. So finally, I mean, obviously AI raises a number of ethical concerns, in a sense, as all technologies and human activities does. They might not necessarily be new. They can be a bit exacerbated by especially the more autonomous AI becomes. I think that's one of my key messages, as I said at the start, that we need to look at specific AI technologies. I think this general discussion can prepare us for this. We might sort of develop tools that we can use, etc. But at the end of the day, we have to look at each specific technology to see what kind of issues are raised by this technology used in this specific setting. And I think we need an improved structure for this kind of ethical evaluation in healthcare. Thank you.